Our learning goal in this video is to determine the nature of roots of quadratic functions. This means that we want to find how many x-intercepts a quadratic function will have if you were to graph it or to solve it. To do this, we use the discriminants. When a quadratic function is in standard form, y equals ax squared plus bx plus c, we take the b value, we square it, and then we subtract 4ac. So b squared minus 4ac is called the discriminant. You should recognize this from the quadratic equation, as it is the part underneath the square root, b squared minus 4ac. So it is important to note that the discriminant does not include the square root. It is only the b squared minus 4ac underneath the square root, inside the square root. So in a question, if you are asked to determine the nature of the roots, or you are asked to find how many solutions a quadratic equation has, you apply the discriminant. So you substitute in b squared minus 4ac, and if you find that your value is positive, which means it's greater than 0, that means your quadratic equation has two real and distinct solutions. So the equation has two real roots. The function would have two x-intercepts. So that means if you had a vertex below the x-axis, it would open up and cross the x-axis twice. And you would have the two solutions. If you were to open down, that means your vertex would be above the x-axis and it would open down. And again, you would see two solutions, two x-intercepts. If you were to substitute into the discriminant and find that your value is equal to 0 exactly, that means your solution is real and equal. The equation has one real root. Your function would have one x-intercept. So how that could look like, it means your vertex is on your x-axis and it opens up. So that your vertex is your only solution. Or you could be on your x-axis and open down. So again, your vertex is your only solution. And that is when the discriminant is equal to 0. The third possibility is if you substitute into the discriminant and you find that you have a value less than 0, meaning it's negative, you have no real roots. So the equation has no real roots, your function would have no x-intercepts. So that means if your vertex was above the x-axis, it would have to open up, and you see that you would have no x-intercepts. If your vertex was below the x-axis and you open down, you would not cross the x-axis and you would have no solutions. We are now going to do 3 examples where we have to determine the number of roots each function has without solving. So the number of roots, that's the key words. Those are the key words in this question. You could also be asked for the number of solutions. Or you could be asked for the nature of the roots. Actually, using the discriminant is not that hard. It's actually less work than using the quadratic formula. However, most students have difficulty recognizing when they need to use the discriminants and also communicating what their answer shows. So in this question, we are asked for the number of roots. We're given the quadratic equation x squared minus 6x plus 9. So again, the discriminant is b squared minus 4ac. Here, b is negative 6, so negative 6 has to go in brackets, minus 4 times a, which is 1, times c, which is 9. And now I will evaluate 36 minus 36, which is equal to 0. So then I will state that as the discriminant, b squared minus 4ac equals to 0, there is one real root. So to get full marks, I have to evaluate the discriminant and then interpret it. State if the discriminant is equal to 0, greater than 0, or less than 0, and then what does that mean? How many roots are there? In this case, there's one real root. You could also word it as there's one real and equal root or one repeated root. In this second example, I want to determine the nature of the roots of x squared plus 5x plus 6. So I will evaluate this. B is 5, so 5 squared minus 4 times A, which is 1, times C, which is 6. So we get 25 minus 24, which is equal to 1. So what I care about is the sign of this discriminant value, which is 1. So I only care that this 1 is positive. So because it is positive, because the discriminant b squared minus 4ac is greater than 0, meaning it's positive, there are 2 real roots. You will often hear there are 2 distinct roots, meaning that there are 2 different roots. They're not the same value. In the final example, we want to find the number of solutions of the quadratic equation x squared minus 6x plus 10. So I will substitute that into my discriminant. B is negative, so I'm going to put it in brackets, times 4 times A, which is 1, times C, which is 10. Negative 6 squared is 36. And then I'm going to subtract 40, and I get a negative discriminant. So again, I need to state what that means. So I will say, as the discriminant is less than 0, there are no real solutions.